Hey everyone, Daniel here. Today we're diving into Auto-GPT for online decision-making, benchmarks, and additional opinions. TLDR, Auto-GPT-style agents powered by large language models can handle interactive online tasks, and when you give them high-quality suggestions from a smaller expert model at inference time, performance improves, especially with GPT-4. Concretely, on the web shop benchmark, GPT-4's success rate goes from 0.24 to 0.32 with additional opinions. On ALF World, GPT-4 goes from 0.485 to 0.515 with advice, and precision rises to 0.789. That's the punchline.
Nice. Thanks for the headline, Daniel. Quick who's who before we get deep. Who wrote the paper and where are they from?
3 authors, Hui Yang and Sifu Yue, are from Amazon in the United States, and Yunzhong, he is from Kaito.ai, also in the United States. The paper is an arXiv preprint from 2023.
Got it. So what problem are they tackling and why now?
There's been a wave of interest in so-called autonomous agents built on top of large language models like Auto-GPT. These agents can plan, call tools, and iterate on their own steps. But we've lacked clean, apples-to-apples evaluations on online decision-making tasks, meaning settings where the agent must act step by step in an uncertain environment. The authors target that gap and also ask whether a lightweight second opinion from a task-specific expert can nudge an LLM agent to do better without fine-tuning.
Makes sense. What's their core idea? I'm curious how they add that second opinion without retraining anything.
They adapt an Auto-GPT-style loop to each task and treat available actions as tools. Importantly, each tool comes with 1 to 3 tiny in-context examples. They found those examples matter a lot for stable tool use. Then they introduce additional opinions. At each decision step, the system can paste in top-K suggested actions from an external expert model. In this paper, the expert is an imitation learning agent trained for the task. The language model still decides, but it sees the suggestions as reference, phrased like, "Here's one or a few suggestions, please use as a reference and make your own judgment." No fine-tuning, just structured advice in the prompt.
So it's like giving the agent a colleague's tips right before it acts. Okay, walk me through the experiments.
2 interactive benchmarks. First, Webshop, a simulated e-commerce site with about 1.18 million products where the agent must search, browse, set options like size and color, and buy the correct item. Second, ALF World, a text-based environment aligned with Alfred household tasks, like cleaning and placing objects with textual actions.
And the setups and baselines?
For Webshop, they evaluated the first 50 test instructions to control cost. Baselines include imitation learning models with and without image embeddings, and a simple rule that buys the first item after search. For ALF World, they use 134 unseen tasks and an imitation learning agent trained with Dagger, with and without a beam search variant. For the Auto-GPT core, they compare GPT-4, GPT 3.5, Claude, and Vicuna. Temperature is set to 0.01 to reduce randomness. For advice, they feed the LLM the stronger imitation learning model's suggestions. In Webshop, that advisor can use image embeddings, while the LLM agent itself does not.
That asymmetry is worth noting. Okay, results on Webshop first?
Right. GPT-4 as an Auto-GPT agent achieves a success rate of 0.24. With one advisor suggestion, it rises to 0.30, and with top 5 suggestions, it reaches 0.32 and the highest reward. GPT 3.5 goes 0.12 to 0.20, then 0.23 with top 5 advice. Claude moves from 0.14 to 0.24 with advice, then around 0.22 with top 5. A key ablation is that random suggestions crush performance. For GPT 3.5, the success drops to 0.06. Vicuna basically fails in this setup. The imitation learning baselines alone score around 0.213 without images and 0.227 with images.
So meaningful advice helps, junk advice hurts. How about ALF World?
The imitation learning baseline without beam search has a success rate of 0.179, and with beam search it's 0.306. GPT-4 as the agent scores 0.485, and with advice it climbs to 0.515. Precision improves from 0.628 to 0.789. Claude is low, about 0.082 success, nudged to 0.090 with advice. GPT 3.5 starts at 0.075 and actually drops to 0.030 with advice, showing that lower capacity cores can be derailed by suggestions they can't filter.
What metrics did they report in general, just so listeners can map the numbers?
For WebShop, they track success, reward, precision, and purchase rate. For ALF World, they report success, reward, precision, and completion rate. One nuance on WebShop is that imitation learning baselines often show higher reward, partly because they purchase more often and are allowed more steps, 100 versus 20, whereas the LLM agent has stricter limits.
Gotcha. Any practical notes on speed or latency?
Yes, the paper remarks that calling Claude's API was faster than GPT 3.5 and much faster than GPT-4 in their setup. They suggest Claude could be attractive when you care a lot about latency.
All right, let's put on the skeptic hat. What should listeners watch out for?
First, sample size. WebShop uses only 50 test instructions. Most base Auto-GPT runs are single runs at low temperature, and the advice-augmented variants average 2 runs. Promising, yes, but we'd like larger test sets and confidence intervals. Second, perception asymmetry. In WebShop, the advisor can use image embeddings, but the LLM agent can't, so some gains may come from extra perceptual information, not just the advice mechanism itself. Third, generalization. This is 2 benchmarks, not the whole world of web or robotics tasks. Fourth, sensitivity to suggestion quality. High-quality suggestions help GPT-4 a lot, but random suggestions or poorly matched advice can harm smaller models. Finally, reproducibility depends on closed-source APIs, which can change over time.
Yeah, that all tracks. If I'm a practitioner, what's the actionable takeaway for tomorrow morning?
Use a strong core model like GPT-4 for the agent loop, keep temperature low, and give each tool 1 to 3 crisp examples. Add a lightweight task-specific expert to propose top K next actions, paste those opinions into the prompt as suggestions, and let the LLM decide. Monitor success and precision, plus cost and latency. If you run smaller cores, consider gating or filtering advice quality so it doesn't overwhelm the agent.
Nice. And future directions you'd like to see?
Scale the evaluations with larger test sets and multiple seeds so we can report proper confidence intervals. Give the LLM and the advisor the same modalities to isolate the benefit of advice versus extra information. Learn a gating policy so the agent can decide when to use or ignore advice. Turn those opinions into a training signal so the agent improves over time. And standardize cost and latency reporting, since deployment often hinges on those trade-offs.
Perfect. Quick recap for the road?
Here it is. Auto-GPT-style agents can be benchmarked on realistic online tasks. GPT-4 as the planning core beats task-specific imitation learners on both WebShop and ALF World. Adding additional opinions, meaning top K suggestions from an external expert, further boosts GPT-4 from 0.24 to 0.32 on WebShop and from 0.485 to 0.515 on ALF World, with notably higher precision on WebShop. Gains depend on suggestion quality and model capacity, so build with care.
Love it. Thanks, Daniel, and thanks everyone for listening. If you found this helpful, stay tuned for more agent-focused deep dives.